Hey there, and welcome to The Explainer. Got a big exam coming up on the motions of the Earth? Well, you are in exactly the right place. We're about to break down everything you need to know, focusing on those high-yield concepts that are almost guaranteed to show up. So, here's our game plan. We'll start with the Earth's tilt. That's the key to everything. Then we'll cover its two big motions, rotation and revolution. We'll connect the dots to see how they cause the seasons, solve the little mystery of the leap year, and then wrap it all up with a rapid-fire review to make sure it all sticks. Let's dive in.
All right, first things first. We're going to start with the single most important concept you need to grasp. Seriously, if you get this one idea, everything else we talk about today will just click into place. And that idea is the Earth's axis.
So, what is the axis anyway? It's really simple. Just imagine a line going straight through the center of the Earth from the North Pole all the way down to the South Pole. Now, it's not a real physical thing, of course. It's an imaginary line that the Earth spins around, kind of like a spinning top.
Now, listen up, because this is probably the most important thing you need to remember for your exam. The Earth's axis is not straight up and down. It's tilted. It's leaning over. This one little fact, this tilt, is the secret ingredient that explains pretty much everything, from our daily cycles to our yearly seasons.
Okay, so keeping that tilted axis in your mind, let's look at the Earth's first key motion. This is called rotation. The easiest way to think about it, it's just the Earth's daily spin. The official definition is exactly what it sounds like. Rotation is the spinning movement of the Earth on its own axis. It's a constant, steady turn that, well, it never stops. And how long does one full spin take? You know this one. Exactly 24 hours. That number is absolutely fundamental. One full spin equals one full day. So, this 24-hour spin has one very, very direct result: day and night. It's just that simple. As the Earth rotates, the side that's facing the sun gets blasted with light. That's daytime. And of course, the side facing away is in shadow, and that's nighttime. It's a perfect continuous cycle. Okay, now we're going to zoom out. Let's go from the daily spin to the Earth's much bigger annual journey. This is the Earth's second major motion, and it's called revolution. Now, this is super important. Don't get revolution mixed up with rotation. They are not the same thing. Revolution isn't the Earth spinning on itself. It's the entire planet moving along a fixed path, we call that its orbit, all the way around the sun. And the timing for this journey is crucial. One full revolution takes 365 days and 6 hours. Pay really close attention to those extra 6 hours. They might seem small, but trust me, they become very important in a few minutes. So, that full lap around the sun, that's what defines 1 year for us. In fact, every time you celebrate a birthday, what you're really celebrating is the fact that you've just completed another full revolution around the sun. Pretty cool, right? Okay, this is the moment. This is where it all comes together. We're going to combine those two big ideas we just learned about, the tilt of the axis and the Earth's orbit, to finally understand the reason for the seasons. This is a classic exam question, so listen closely. The seasons are not caused by just one thing. They are the result of two things working together. Number one, the Earth's tilt, and number two, its revolution around the sun. You absolutely need both to get seasons. And you can see it perfectly right here. Just look at this comparison. In June, you can see the northern hemisphere is tilted towards the sun. But as the Earth continues its orbit, 6 months later in December, that same hemisphere is tilted away from the sun. It's this changing angle that is the whole key. So let's boil it down. When a part of the Earth is tilted towards the sun, it gets hit with more direct, concentrated sunlight, and the days are longer. That's summer. When that same part of the Earth is tilted away from the sunlight is more spread out, it's less direct, and the days are shorter. And that's winter. Simple as that. Hey, remember those extra 6 hours we talked about? The ones from the Earth's revolution? Well, our 365-day calendar has a problem. It doesn't account for them. So let's look at the really clever solution we came up with, the leap year. The math here is actually really simple. Each year, we have 6 extra hours just floating around. After the second year, that's 12 hours. Third year, 18. And after 4 years, well, 6 times 4 is 24 hours. That's a whole extra day. So to keep our calendar lined up with the Earth's actual orbit, we add that extra day, February 29th, every 4 years. And that's what a leap year is.
All right, we've covered all the core concepts. So let's do a final high-yield review. Think of this as your cheat sheet, with the absolute must-know facts for your test. Pay attention.
Okay, let's lock this in. 1.
Earth has two motions, rotation, which is 24 hours, and revolution, which is 365 days and 6 hours. 2. Rotation causes day and night. 3. The seasons are caused by the tilt of the axis and the Earth's revolution. 4. Because of that tilt, the seasons are always opposite. When it's summer up north, it's winter down south. 5. Those extra 6 hours from revolution add up to create a leap year every 4 years. And finally, all of these rhythms, day, night, the seasons, they never, ever change.
And we'll end on this thought. We've just proven that the rhythms of the Earth's movements are constant, predictable, and unchanging. So the big question to think about is this: how does this incredible, predictable cycle of seasons affect all life on our planet? Think about that. And good luck on your exam.